All right, folks, today we're going to go over some server and client steps that you need to take. The first thing I want to look at is the client. And you'll see that there are a lot of pieces that we need for the client. And I've got some various things included up here, which you'll need, and I'll add some links to where you can find those on my website. First is setting up your connection and connecting to a server. So you can ignore this function for a second. The first thing you need to know about your server is the IP address. I've stuck it in a character string here. And the second thing you need to know about wherever you're connecting is what its port number is. And so you can see I've stuck it at an int here. It turns out that port numbers are not allowed to span the whole range of integers. It's something like an unsigned short or something like that. 0 to 64K, 65535 are valid port numbers. Anyway, this first step, you can just kind of copy verbatim. I'm just setting up the socket and the socket address. The first function that you need in order to connect to a server is called connect. You can see here I'm passing this socket, I'm passing the address stuff, I'm passing the size of the address stuff. This check for this function less than 0 is to see if there's an error. If connect returns a value less than 0, then there was an error. P error is something that translates error numbers into English equivalents, more or less. And so I do a P error here, and you'll see that I do that for most of the system calls inside this particular setup. If this connection was successful, then SF should refer to the socket that is connected to whatever server you're connected to. So you can see I print connection success, and then I call a receive message because in this particular protocol, after a connection, the server sends something to the client first. In a lot of protocols, the client sends something to the server first, but in this one, the server sending something to the client first. I'm going to go over the receive message function in a second, but it receives a message and outputs it to the console. And then, let me scroll down here, and then I ask the user to give me some input, and I do a scanf for that. You guys might be used to cout and cin. A lot of times when I'm working in system code, I'm working at a lower level, so I'll switch back to printf and scanf in the old C style. You can use cout and cin. It changes a little bit of things, and I'm going to make a subsequent video, or depending on the length of this video, I might attach it to the end about how to deal with all of these conversions between the standard string and the C string here in a second. Anyway, you have some character buffer, some character array of information that you want to send back to the server. Again, in this particular setup, the server sends something to the client then sends something to the server, and then the server shuts down the client and the connection, and the client closes. And so in order to send, you use a function called send, and you pass it the socket descriptor that we had before, along with the character buffer, how many characters you want to send. String length works here because of the way scanf and C strings work. String length might not work depending on how you're handling what you're sending. But basically how many characters I want to send, how many bytes I want to send is what's being noted here. The 0 is for some other things we're not going to use. And again, since this is a system call, I check to see if the result is less than 0, and if it is, that means that it was an error like most system calls. Now, we've skated over one thing, which is how do we do a receive message? As you might imagine, it's just another receive call, but I've added a few pieces of things around it. Basically, a receive call passes a socket descriptor, a buffer where the data is going to go, how many bytes maximum you possibly want to receive, along with some other options. This used is the value that's returned from receive, and usually it will be a positive value representing the number of bytes that you received from the buffer. If it's less than 0, there was an error, so you can output that. And then I print out how many I received, and then I walk through the character buffer, outputting each of those. If you don't zero out your buffer before you receive to it, it's possible that you'll need to use this kind of step. You could output the buffer as a string, and that should work fine as long as the buffer has zeros in it beforehand. And anyway, then I print a return. This is all the client does. So there's really only 3 functions. There's a connect, a send, and a receive. And managing those in the right way is all of that your client needs to do in order to make a network application. Now, of course, there is a client application which requires a couple of more steps, a little more work, but let's talk about that now. Switching over to, there's a server application which requires a few more steps. Switching over to the server. You can see I'm relatively including the same stuff. I actually have this exact same receive message function call in here. I'm going to do it the same way in the server and in the client. I did a copy paste. In my applications, I usually stick that stuff in a header, anything that's going to be the same. I set up the socket and everything, but you'll notice that right away the system calls that I have to make are automatically different. The first one's a bind, and the bind is where you basically ask the operating system if you can have that port number, if you can bind to that port number to listen for things. Then I listen for incoming connections. So when somebody actually connects, then no, I listen on that port. I tell the OS, okay, fine, you gave me the port, now I want to listen on it. And then the next function call is an accept. And so you can see up here that I'm passing S, and S is my server's kind of socket descriptor where it's listening to the port, where it's getting connections. Anyway, so this accept function call is where you actually accept a client. And I'm passing in a few different data structures here, which are basically just holding the information from the client. And what I do in this server is I output some information related to the client, basically their IP address and port, just so that you can kind of check what's going on and how these things are working. If you remember, our particular application level protocol says that the server sends the client something first and then the client responds. In this particular case, the server is going to just send this string hello client to the server. The server is going to send the string hello client to the client. I do that with a send just like I did before. This isn't really different than the other thing that you saw. So this works just like expected. And then I receive something from the client, and I do that using the receive message. Now, one thing that's different that you didn't see before are shut down and close. Either side can really shut down their side of the connection, and you can do that with this shutdown command, and close will actually close the connection. One other thing that I should point out is there was a shift away from the server's client descriptor to the client's socket descriptor. So when I'm doing an accept, I'm doing it on the server descriptor, and then I'm passing that to the int C, and C becomes the socket that corresponds to my actual connection with the client. And so this send is with C. Maybe it should be something like CSF or something like that, and maybe the S should be something like SSF. But I send with C and I receive with C, but I accept with S. So I'm accepting on the socket in which I'm listening, okay? But I'm sending on the socket with which I have made a connection with a client. So the server has to manage a couple of different pieces. You can see for the most part that as far as the communication goes, this stuff all looks the same, or at least this stuff does. The only thing that's really, really different is that you have to bind, listen, and ultimately start accepting connections. Now, if you're going to do this for some sort of server that's going to accept multiple connections, you have to get more clever here, use some threads or forking or something like that in order to allow it to handle and process multiple things at the same time. We're not going to do that right away for the applications that we're going to build, but that is something to keep in mind. This in address any that you see here basically says any available IP address that I can use it. And so that's useful to have in your wheelhouse, I guess. Usually that's going to mean there's only one, but if you're on a big server that has multiple network connections, then it might bind to different ones based on what's available. Anyway, the last piece of this is how do you deal with conversions? If you're used to C++, how do you deal with conversions to deal with all this C-string stuff? And so I think, well, I don't actually have the source here, but I can talk you through it a little bit. So the first thing that you'll notice is that I'm using scanf and printf all the time. It doesn't really change things if you use cout and cin for these things. All of that, it will work just dandy. What's different is I never use the string, the standard string class. So let's actually manage that a little bit. So I'm gonna jump back over to the client a little bit, and in the client you'll see down here that I asked the user for input with a scanf. So you could do that with a cin, and you can even do it with a cin to a string. So let's say I wanted to read in the string s. Okay. One cool thing that the standard string class has in it is the ability to convert it back into a C string, and so you might find that to be really, really useful. so that you can change the way this send works by using s.c_str, and that gives you the C string that corresponds to some string. Another thing that you might have to figure out how to do is how to get numbers into a string or into a C string. There are a fair number of ways to get numbers out of a string. You can do things like A to F in order to convert things from a character array to a float, or A to I to convert things from a character array to an integer. So even if you have them as a string, you can convert that to a C string and then use A to F or A to Y on it to get the float or integer out of it. But what's slightly more challenging, I suppose, is how do I get stuff into a string when I'm given just an integer. So let's say I have the integers A and B here, and maybe they're modified by user input or some calculations, and how do I get those actually into a C string so I can use them? String stream is the way that C++ handles this, and so you can create a string stream object, and then, sorry, I'll probably have to call this something else, and then push things into the string stream object. So like A is A, B is, using all of the C ++ notation that you're kind of handy with, using cout and things like that. And then of course, if you need to get the string related to this SS, there's an ss.str, and then if you need the C string related to that string, you can do ss.str.cstr. I feel like at this point, if you're working on writing network applications at this level, that you have the ability to kind of go look up string and ostring stream to get some more info. I'll put a link to something that does some sample pieces of this in the comments, but otherwise grab a reference, try things out, try it without network code being involved, right? That's a good way to learn how a piece works, rather than trying to force it directly into implementation into one of your projects. It's pretty straightforward, but it can be tricky because C strings are a little scary for a lot of folks who've never messed with them. Okay, that's a quick run through of how the client and server work. I haven't really showed you that they work, and that's kind of hard to do with only one screen. But if you can imagine, I run the server and I'll push its output to server output.text, and I'll do that in the background. And then I run a client, and then I can type some things in here, and then I can run the client again and connect to the server. And you can see that each time I do this, I'm connecting to the server, and the server is sending me hello client. One thing you'll notice is I'm not putting any spaces in this. That's on purpose. If I go ahead and close the server down here, whoopsie. I'll go ahead and close the server and look at this server output.text. Oh, look at that. Because I killed the server like that, it's empty. Oh, that's unfortunate. Okay, let's do this a different way. I'll go ahead and run the server in the background, and then I'll push the client's output to nowhere. Okay, and so you can see this is the server's responses to the clients. It's and all the things that are written in there. Well, I think that concludes our video. I went through things pretty fast. Again, I'll leave the source so that you can kind of walk through that a little more quickly. But send and receive are the basic steps. The server needs to bind, listen, and accept, and the client needs to connect. And otherwise, that's how you build network applications. All right. There are some key points to certain port numbers that you connect to. If you're not aware of those, make sure that you go look that up. Use higher port numbers if you're having some troubles trying to bind to something low, because there are some OS protections around some of that stuff. I think that's all for this time. So until next time, goodbye.